Hey everybody, I am recording our video for your lesson for Tuesday, March 8th. Today is the last day that I'm going to be gone. When we come back to school on Thursday, I will be here, and trust me, you guys, it's been a really hard week, and I'm just really looking forward to coming back and seeing you guys and just getting back to normal again. I really, really miss you, so can't wait to see you on Thursday. Here's what we're going to do today. We're going to review your mid-unit assessment questions. And then I'm hoping that I have enough time on the video. I don't want to go, obviously, over 47 minutes because that's how long our class period is. But I want to also kind of talk to you about the article, What Happens When Fuel Burns. And the purpose of that is to understand any misconceptions and prepare for your unit test. Your homework today is just a study. Here's our calendar for the week. So it's a crazy week for us. We didn't have school yesterday. Here's today. We're just going to do our little video review. Tomorrow we do not have school. Thursday you will have an end of the unit test if the boys win on Wednesday. Okay. If they win on Wednesday, that means they're going to play again on Friday. And I have read some emails that say that we're going to have a modified schedule on Friday, but I have not actually seen that modified schedule. What that means is probably we'll have an early dismissal or our class periods aren't going to be as long. And I don't want to do an end of the unit test on a shortened day. That makes no sense. People aren't going to finish, and then we'll have to finish it when we come back from spring break, and that's just a nightmare. I want to be done with this unit and be able to move on fresh when we get back from spring break. So if the boys win on Wednesday, plan on an end of the unit test when we come back on Thursday. Now, if the boys do not win on Wednesday, we will come back to school and have a vocabulary and key concept test. This is going to be summative, and it will force you to study so that you're ready for this end of the unit test. The vocabulary and key concept test is going to be just that. Remember how we had it before, where I've got the vocabulary terms, and then you guys have to write in the definition. And then I've got key concept number 1, 2, 3, 4, 5, 6, 7, 8, 9, and you have to write in the key concept itself. Okay? So if they win on Wednesday, we're just doing the end of the unit test on Thursday. We'll do something else on Friday. I'm not quite sure what. If the boys do not win on Wednesday, we're going to do a vocab and key concept test on Thursday, and then your end of the unit test, which is Amplify, is on Friday, and both of those would be summative. Okay, let's come here. I want to show you why I want to review. I'm a little concerned about your mid-unit tests. You guys struggled, man. You guys really struggled as a whole class, like all my class periods. Really concerned about the trend that we're showing here on this mid-unit assessment. Let me explain what you're seeing. This is period 1. This is your pre-unit assessment. So this is before you had any information. This is just you getting started, without any information. This is the mid-unit assessment, and it's very concerning to me because 64% of you guys scored a PB0 before you had any information, any knowledge. And then after 2 chapters, more people scored a PB0 than when you didn't know anything at all. So that's incredibly concerning for me. I know that only 9 people took this test, and basically the numbers break down to this. 6 of you are at a PB0, and then 1 person's a PB1, 1 person's a PB2, 1 person's a PB3. That's very concerning to me. Let's take a look at period 3. You guys did not do a lot better. It's also very concerning. You'll see that 52% of you are at a PB0. Half of the class, after 2 weeks, still did not demonstrate any understanding of this chemical reaction unit. And you guys, what that tells me is you are not studying. You are not studying your key concepts, or you rushed through this and you didn't read it very carefully, or you don't understand the questions or how it's being presented to you in Amplify. And so that's one of the reasons why we're going to go over it today. Let's take a look at period 4. Period 4, you guys fared a little bit better. I've got 44 of you guys, 44% of you at PB3, 19% at PB2. You guys, this is what I would really like to see. By this time, we should have the majority of the people here at PB2. And so to have PB2 and PB3, this is great. But it is concerning for me to say 37% of you, so more than a third of the class is scoring at a PB0. That is like, what? Come on, you guys. That makes me really, really concerned. 5th period, you guys did very well. Take a look at this. So you can see where we had kind of higher numbers here, and now we're really trending up so that, hang on, so that a lot of you guys are at a PB3. We still didn't have anybody scoring at a 90 percentile to demonstrate complete mastery of this yet, but you're on the right track, and this makes me happy. So let's go ahead and just get out of here, and let's take a look at the questions. It's important for me that I kind of talk you through how I approach these questions so that you can use the same strategies when you take the end of the unit test, which is also going to be on Amplify. So Amplify does not use the atomic models that we're used to maybe in the sim. You'll notice that there are no element symbols on these atoms. They use color and they'll use pattern to represent different molecules and individual atoms in those molecules. And that's okay. It's a model. That's okay. So let's talk about this. Question number 1, when I first look at this question, I realize right off the bat that sample number 1 and sample number 2 are different. And the reason why is because even though they both have this same color, this bluish color here, sample number 1 has an atom that is yellow and sample number 2 has an atom that is green. Their repeating groups of atoms are in this little key here. So I know sample number 1 has 3 molecules of this substance, whatever it is, and sample number 2 has 6 molecules of this substance, whatever it is. And these substances, because they're different colors, are not the same atoms. Now, what do you know about that? There's lots of stuff that we can think about with key concepts. But specifically, because we're looking at the atomic model, I don't want to say key concept number 1, different substances have different properties, because I'm not looking at the properties yet. I'm looking at an atomic model. So I'm thinking of key concept number 4, which says different substances have different properties because they are made of different groups of repeating atoms. So even before I read the question, hang on, I got to cough again, hang on. Even before I read the question, I'm totally aware of what I'm looking at in comparing sample number 1 and sample 2. So when I get down to the question and it says, this diagram above shows the repeating groups of atoms that make up 2 samples. Will the properties of the 2 samples likely be the same or different? Well, I've just had that conversation in my own head. I know they're different, and I know they're different because they have different groups of repeating atoms. And so the answer would be B. That is the key concept number 4. Some of you guys said key concept A, and I just want to, remind you that it really doesn't matter how many groups of repeating atoms we have. That doesn't affect the property. So just because I have, more repeating groups of atom, that doesn't change a color or that doesn't affect the boiling point. It just means I've got more of that substance than the other one. So the number doesn't make a difference, okay? Let's take a look at number 2. Again, I encourage you to look at the graphic first and really truly understand what you're looking at before you read the question. So I'm looking at this graphic and I can see immediately that I've got an arrow here, and that tells me I'm looking at a chemical formula. And so I'm looking over here. Yep, I do have a chemical formula because here's my plus sign. So this represents the reactant. This represents the product. I've got sample number 1, sample number 2. If I look at my properties, I can see that this is a colorless liquid and it melts at 12 degrees Celsius. Sample number 2 is a yellow solid and it melts at 90 degrees Celsius. And then I have an ending substance that is a gray solid and it melts at 1340 degrees Celsius. I know all of these are different properties. They have different properties, and so therefore they are different substances. So I'll come down here and I'll read my question. You guys, this is where you guys get tripped up because unfortunately Amplify is very wordy in their questions. So really pay attention and highlight what exactly is it that they're asking you. It says a scientist mixed together 2 samples, a colorless liquid that melts at 12 degrees Celsius and a yellow solid that melts at 390 degrees Celsius. She analyzed the results and found 2 ending substances. One of the ending substances was a gray solid. This ending substance is made up of the repeating groups of atoms shown above. Which diagram to the left shows the repeating groups of atoms that make up the samples the scientists mixed together? So even though it tells me in here that I had 2 substances, we're really focusing just on this one. And it's asking which one of these could possibly be the substance that made this. So let me explain. This one's confusing, and I'll give it to you. This was one of the most missed questions from all of the classes. And I want to explain what kind of they're showing. This ending substance has a yellow and a black atom. Okay, so answer A, if I chose answer A, that means this yellow and black would be the same, so therefore it would have the same properties. So it can't be yellow and black because it has different properties. So it can't be A. Look at B. B has all of these colors, and there is a yellow here. And sample 2 has all of these colors, and there is a black here. So is it possible for us to take a yellow and a black to make this? Yes, it is. So the answer is B. Let me tell you why it's not C. Do you see a yellow in sample C or in letter C at all? There's not. And so there's no way C can be the answer because remember, key concept 8 or 9 says atoms cannot be created or destroyed. And so we can't have this yellow atom coming out of nowhere in the product. It has to come from the reactants. So it cannot be C. And then the same thing is true for D. There is no black. So again, atoms cannot be created or destroyed. So the only answer that makes sense is this sample B because the yellow comes from, or answer B because the yellow comes from sample 1 and the black comes from sample 2. Okay, so then you would just click right here, diagram B. Let's take a look at number 3. Number 3 says we've got this starting substance. Okay, so yellow, or I'm sorry, good grief. Green and purple plus yellow. Shannon Clayton. Let me start again. Green and purple plus blue and red yields what could possibly be the outcome? Well, it says a company that makes frying pans needs to create a new substance to coat the pans. This substance must have a high melting point. To create this new substance, workers mix together 2 substances that melt at low temperatures in a sealed container. The diagram above shows the repeating groups of atoms that make up the 2 starting substances. Remember, those starting substances are called the reactants. You guys, I'm going to tell you something. This whole paragraph is just background information. It has nothing to do with the answer. It's just kind of setting up the scenario, like a real world scenario in which something like this would happen. This is what you need to focus on. After mixing, the workers found two substances that melt at a higher temperature than in the sealed container. In other words, nothing escaped. Which of the diagrams to the left shows the repeating groups of atoms that make up the ending substance? So I've got 4 atoms in our starting substance. How many atoms should I have total over here? Well, again, if you remember, and again, I apologize, I want to say it's key concept 7. Basically, all of the atoms in the starting substance or at the beginning of a chemical reaction are in the ending, in the product. All of them. Atoms are not created and they are not destroyed. So if I start off with 4, I've got to end up with 4. And if it's a chemical reaction, these atoms have to have their bonds broken and they're rearranged. So they're not going to come back together as the same thing again. Okay? So if I look down here, which one could be the possible ending substance? If I look at A, I want to look at it and go, okay, well, there's a green from sample 1, and here's a red from the second one, and here's a blue from the second one, and a purple from the first one. In other words, these two have to break apart and then connect with the opposite one. So it has to be A. Okay? Why can't it be B? I'm going to give you guys a second to look. Why cannot it cannot be B? Why not? It can't be B because B has 2 reds. Okay? There was only 1 red up here. So remember, atoms cannot be created or destroyed. We can't just come up with another red one. Also, atoms are not switched. They don't turn into another type of atom. So we're missing the purple in this one. It can't be B. Why can't it be C? Same reason. Because it's starting out, basically all we did here is we just switched them over here, but they're still the same pairing. This is still green and purple, and I've got green and purple right here. And this is blue and red, and I've got blue and red right here. So it cannot be C because there was no chemical reaction. These bonds didn't break and they didn't rearrange. They just switched places. So C is not the right answer. D is not the right answer. How come? It's not the right answer because I have an extra atom. I've got 1, 2, 3, 4, 5. Atoms cannot be created or destroyed. We've got this black atom right here that was not in the starting substance, so it cannot be that one. Okay, so again, my answer is diagram A. Let's move on to number 4. So number 4 looks just like, now we're starting to repeat the same questions over and over again. We've seen this before. What I'm looking at here is a repeating group of atom that goes yellow, blue, yellow. Okay, so it's a group of 3. Okay, yellow, blue, yellow. And there are 4 molecules here. This one goes blue, yellow, and there are 2 molecules. Are sample 1 and sample 2 the same or different substances? They are different substances. Why? Key concept number 4 says different substances have different properties because they are made with different groups of repeating atoms. So again, even before I read the question, I know these are different. I know they're going to have different properties. So let's take a look at the question. Basically, it's a repeat of question number 1. It's asking, will the other properties of the sample likely be the same or different? They are going to be different because the repeating groups of atoms that make up the 2 samples have different numbers of atoms. Okay, let's take a look at number 5. Number 5, again, we've seen this before. We're looking at the reactants. We're trying to figure out what the reactants could possibly be, but here's our ending substance. So we've got a purple, blue, pink, yellow. We know that none of these are the same, so I'm not going to have a molecule with these 4 in it over here. They're going to have to be mixed up somehow. So I'm looking at the question, and it says scientists mix 2 samples together, a white solid that boils at about 800 degrees Celsius, colorless gas that boils at about 70 degrees Celsius. He analyzed the results and found 2 ending substances. One of the ending substances boils at 245 degrees Celsius. This ending substance is made up of the repeating groups of atoms shown above. You guys, when you read this, when you see it in the test, I promise you, all of this information right here is just background information. One of the big things at like for state testing is they really want science or want all of the questions to be based on real world problems. And so that's why they give you all of this like background information. This is just background information. It has nothing to do with the question. The question actually starts right here. This ending substance is made of repeating groups of atoms shown above. Great. So we're looking right here at this repeating group of atoms. And it says which diagram to the left shows the repeating groups of atoms that make up the samples the scientists mixed together. All right. Like I said, we've got 4 atoms. So if you have one that has 4 atoms, and I've got 1 purple, 1 blue, 1 pink, 1 yellow, I have to have each of these represented some way, and I cannot have anything that is the same substance because it has different properties than any of these over here. Okay, so if I look at sample 1, I can see I've got greens, I've got a dark green, light green, pink, and yellow, and then I've got another pink, I've got a red, and 2 purples. I'm missing this light blue. So it cannot be A. If I look at B, I see I've got pink, I've got red, I've got blue and purple, I've got green, black, and red. So can it be B? No, it can't. I don't have the yellow. Look at C. I've got, boy, my lighting is really bad. I think that's 2 purples, a green, and a blue. And then I've got a yellow and a pink. So do I have a purple? Yes. Do I have a blue? Yes. Do I have a pink? Yes. Do I have a yellow? Yes. So C is a possibility. And I'm going to hang on to that in my thought for a second. And I go down to sample D and look, it's exactly the same formation, the same number, and the same repeating group of atoms as our ending substance over here. It cannot be D because these have different properties. So it cannot be this repeating group of atoms. So my answer is C. I'm hoping you guys understand and you can follow along my reasoning behind all of this, okay? I'm going to keep going, and I'm going to pause as I go through these questions, and I want you guys to see if you can guess the right answer, okay? Especially those of you guys that missed these questions to begin with. So we're doing kind of a review here, a revision. Okay, so now we've got another question that's looking at the end product. Remember, this over here is the reactants. This is the product. I know I've got a chemical equation because I've got a plus sign and a yield sign. We've got 2 substances that we're looking at here. This is a light green and kind of a dark green. I've got purple and I've got blue. So remember, all of this right here is sort of background information, right? After mixing these like chemicals, Andreas found two solid substances in the sealed container. This right here, where it says nothing had escaped, that's included because it doesn't, they don't, one of the key concepts is that atoms do not, they're not created and they're not destroyed. And they didn't want you to think, well, what if in the jar the lid was off and it became a gas and it escaped and so it's no longer in the container. They wanted to take all of that questioning out for you and just make sure that you knew that everything that we started with, that's what we ended with. Okay. So again, how many atoms do we have? We have 4 atoms. We have these colors and they have to be represented over here. I cannot have this pairing over here because we have different properties. Okay, so let's take a look. A, B, C, or D? I'm going to pause a little while and I'm going to have you guys make your choice. Okay, I hope you chose A. Let me show you why. Diagram A has to be the only answer because here's my green, and I don't have a dark green with that one. I have the blue, which comes from this one. And then in the second substance, substance 2, I've got the purple, which is right here, and that's paired right here with this green one. So basically, again, these atoms, these 2 pairing atoms broke apart and they rearranged. So this had to go with one of these and this one had to go with the other one. So it's A. It cannot be B because we have an extra atom. We've got 5 atoms here and I only had 4 here. It cannot be C because we have exactly the same atoms, the same molecules. They're just in different places. I can't have the same molecules because it says here that they have different properties. And then it cannot be D because no atom is ever changed into a different type of atom. So I can't take this purple and it can't change into another light green, which would happen here. I don't have the purple in this one, but I have 2 light greens, and that cannot happen. That's one of your last key concepts. All right, let's keep going. You guys are on a roll. Number 7. So here's my repeating groups of atoms. I've got green, orange, green, orange, green, and then orange, green, orange, green. Are they the same? No, they're not the same. They have different repeating groups of atoms. So do you think that the properties of the 2 samples are likely going to be same or different? No, they are not. Do you guys see how easy this test is? It's the same question over and over and over again. Why won't they have the same properties? Why won't they have the same properties? The reason why is because the different groups of atoms that make up the 2 are different. That's key concept number 4. Okay, let's move on to number 8. Number 8 again, this is the 3rd time we've seen this type of question, so you guys hopefully are getting really good at this. We're looking at the reactants. I see my ending substance, and I can kind of predict that this is, I can't have this be repeating because I look at my property, it's green gas with no smell, and these properties are all different. Okay, so I know that this is going to have to be made of something that was not this combination before. So I'm going to say, here's my background information. Okay, and then it says, which of the diagrams to the left shows the repeating groups of atoms that make up the sample that Jacob mixed together? What could this be? I'm going to let you guys guess. Take a minute. Okay, what do you think? Did you say B? If you said B, you are correct. Why is it B? I've got 2 reds and a blue. Here are my 2 reds, and here's my blue. If I look up here, I don't have the light blue. Sample C, it's the same grouping of atoms, which means it's going to have the same properties. And I don't have those same properties, so it can't be that. And sample D, what the heck? Where are my reds? They're not there. So it only can be B. Let's take a look at 9. I'm hoping you guys are getting this. So I've got my starting substance here. I've got 2 greens, and I've got a blue and a red. And I'm trying to find out which of the diagrams to the left shows the repeating groups of atoms that make up the ending substance. I'm going to give you a second to look at it. See if you guys can figure out what it is. Okay. Is it A? Nope, it's not. Because all A is just kind of mixed around together, right? They just changed spots. But the red is still with the blue, and the 2 greens are still together. These have different substances. Or I'm sorry, these have different properties. So it cannot be this one. How about B? Is it B? No, it's not. Because an atom cannot change into a different type of atom during a chemical reaction. So I'm missing my red. I've got 2 blues and no red, so it cannot be B. Can it be C? It can be C. Because remember, atoms can stand alone. Think about what? Gold. Maybe this is a gold atom, or maybe this is another repeating atom like iron. And then, so here's my 1 blue and 2 greens. These are now a completely different substance. And then I've got my 1 standalone. So the answer is C. Why can't it be D? Can't be D because I've got 4 atoms up here and I've got 5 down here. Atoms cannot be created. So that makes no sense. This light blue one right here, that's not anywhere near it. There's none of them here. So my answer has to be C. Okay, let's look at number 10. Ooh, this one's tough. Here's a repeating group of atom. Here's a repeating group of atom. What do you notice? Even before you look down here, is this the same? Are they in the same arrangement, same number, same colors? They are. So if this is orange, red, purple, what do you know about these? Are they the same? They are. So are they going to have the same properties? They are. And is the same property because of the number of molecules? No. Remember, key concept number 4 says different substances have different properties because they're made of different groups of atoms. If we have the same group of atoms, it makes sense that they're going to have the same properties. So as we scroll through and we say, look at the question, it says, will the other properties of the samples be same or different? We know they're going to be the same. And the reason is because they are made of the same repeating groups of atoms. Make sense? Okay, let's look at number 11. We're looking at the reactants. Here's my product. I've got a pink, a green, and a yellow. I look real quick. I see that these are two completely different properties. So that means sample 1 and sample 2 are not the same sample. They're not the same substances because they've got different properties. That's key concept number 1. And the ending substance is also different from either of the two, sample 1 or sample 2. So scrolling down here, it talks about how they have all different properties. And it says, which of the diagrams to the left show the repeating groups of atoms that make up the samples the chemist mixed together? So, which one could have combined, which answer includes a sample 1 and sample 2 that could have broken apart, rearranged to combine this ending sample? So we'll take a look. I'm going to let you guys choose. Okay, let's take a look. Is it A? So I've got pink, green, yellow. I'm missing the green. Can't be A. Look at B. I've got black, green. I don't have pink. I've got the green and the yellow, but no pink, so it cannot be B. Take a look at C. Unfortunately, C is the same substance as the ending substance, which cannot be the same over here for 1 and 2 because we've got different properties. So I know these are going to be different substances, so it cannot be C. My answer is D. And so I've got, here's my pink and my green and my yellow. So I've got this one here, which means this is only one of the ending substances. Chances are that last substance is going to be this one all by itself. That wasn't the question. It's just trying to find out where the answers, or where did these atoms come from. So this is our reactant right here. Let's take a look at the last question. So we're looking at the product. Here are my starting substances. How many atoms do you have? 1, 2, 3, 4, 5. So my starting substances here, I've got 5 atoms. This is one substance. It's different than this one. They're going to have different properties. Substance 1 and substance 2, all of those combined are going to have no more than 5 atoms because that's what I started with. So go ahead and take a look. Which of the diagrams to the left shows the repeating groups of atoms that make up the ending substances? All right, can it be A? No, it cannot. And the reason why is because I've got a purple and an orange together, which is exactly this one. And this pairing or this grouping, black, light blue, and green, which is the same as that one. So, you know, in a chemical reaction, it says that the molecules or the atoms break apart and rearrange to form a new substance. And that didn't happen here in A. So it cannot be A. How about B? Well, it can't be B because I've got this red one right here. I'm going to tell you really quickly, you guys, sometimes these colors get a little bit confusing and your eyes get a little bit buggy. Count your atoms first. So I've got 5 here, I've got 6 here. Without even trying to figure out which one's the wrong color, I know that's not right. Remember, atoms cannot be created or destroyed. So I can't start with 5 and end with 6. That just doesn't work. How about C? So I've got 5 up here. I've got 5 down there. Let's check the colors and make sure it's right. Do I have a black? I do. Do I have a purple? I do. Do I have an orange? Yep. Do I have a light blue? Yep. Do I have a green? Yep. Are any of these the same as what my starting substance was? No. So my answer is C. Let's take a look why we can't have D. Immediately, do you guys see this 2 green? I didn't have 2 green up here. So this atom changed to a different type of atom. I don't have my what don't I have? My black. I don't have a black one. So this diagram is suggesting that the black one changed into another light green, and that's not possible. Atoms don't do that. So my answer is C. Okay? Woof. That's the multiple choice. When you look at it and you really take the time to look at it, you guys, this should be fairly easy as long as you know your key concepts and you're really taking the time to really look to see what you have. Let's take a look at the short answer questions real fast. This is those of you guys that scored a PB3 on the multiple choice, you were struggling a little bit with your written response questions. It is imperative that you know your key concepts so that you can use those to answer the question. If you guys just use your vocabulary words, if you can use all of the vocabulary words, that will help you to basically cover all the key concepts and you'll be fine. So let's talk about what kinds of things you need to talk about here, include in your short answer. It says Samira watched a demonstration in which a scientist combined two substances in a sealed container and analyzed the results. The ending substance did not look the same as the starting substance. So it's a very good indication that a chemical reaction occurred. Samira was given a diagram with repeating groups of atoms that make up the starting substances, plus information about properties of the starting and ending substances. She created a model of the repeating groups of atoms that might make up the two ending substances. Does her model correctly show why the properties of the ending substances are different from the properties of the starting substance? Describe what could be correct or incorrect about our model. So basically, we were told that a chemical reaction occurred. If a chemical reaction occurred, whatever I had in my starting substance cannot be represented over here in my ending substance. In other words, I can't have a molecule that looks like this in my ending, or this one in the ending. They have to have broken up and rearranged. So again, the very first thing I want to suggest to you is take a look at these groupings. And she was given this. She made this one. The question is asking, basically, does her model correctly show it? And if not, what's right about this and what's wrong about it? Okay. When I look at this, the first thing I want to do is count them. So I've got 6 molecules and I've got 6 atoms over here and I've got 7 over here. So immediately I know that her model that she drew, this second one, is incorrect. And so that would be my first sentence here. Samira's model is incorrect. And then I would say, according to key concept, and you guys, I apologize, I don't have the key concepts in front of me. I want to say it's key concept number 7, according to key concept number 7, or it could be 6, or it could be 8. Good grief, I'm so sorry. No, I'm going to say according to key concept. And then I'm going to put a question mark because I'm not quite sure which one it is, but that's the one that you're going to tell me. According to whatever key concept, no atom. Oh, well, I could just say this. Atoms are not created or destroyed during chemical reaction. Ooh. Okay, so that's one thing. The other thing I want to say is she did do something right. She was correct in showing that the molecules themselves, the groupings of atoms, are different. So I would say she's correct in showing that the repeating groups of atoms are different. You know what, you guys? We need to use the words reactant and product. So I'm going to say that the repeating groups of atoms are different in the reactants and products. So she was right. She showed that. And I think that's good. I really do. So I showed what was incorrect. I showed what was correct, and I showed what was incorrect about our model. And I think I would count that. I need to maybe add a couple more, like a little bit more explanations using vocabulary words. We used a model, whatever. I'm going to be honest with you. If you guys type that in, I would be thrilled, and I would give you 100% for that. So let's go ahead and look at key concept, or at the number 2, written response. Now, I'm not going to give you the answer for this one. I don't want to do that. But I want you guys to consider what we just did for number 2 and what you would write for number 3. Okay? So again, we see this starting substance, and we've got this group of repeating atoms that make one molecule, and this group that makes one molecule. This is the reactants. This is one of the products. Okay? It says a chemist mixed 2 substances together, colorless liquid with a strong smell and a white solid with no smell. The substances' repeating groups of atoms are shown on the left. After they were mixed, the chemist analyzed the results and found 2 substances. We're just talking about one here. One ending substance had the repeating group of atoms shown above on the right. So we're just talking about this one. There's more. There was one more, but we're not talking about that. Is the ending substance the same substance as the colorless liquid? So there's the colorless liquid. Is it the same? What happened to the atoms of the starting substance when the ending substance formed? You guys, describe. It says, please be sure to explain your answers to both of these questions. So you've got this question and this question. Use your key concepts. Use your vocabulary words. Answer both questions. Okay? I'm not going to go over that one. I think I've really done a really thorough job of reviewing these. So I want to make sure that you guys can do it on your own. Okay, you guys. I feel like this is a super long video as it is. I'm going to cut it short. We are not going to go over the article. If you did not read and annotate this thing yet, please do so. If you are still struggling a little bit and you're not quite sure, turn to the 3rd page and read this and this paragraph, and then compare that to this one talking about burning hydrogen fuel to find out exactly what are the steps, what happens during a chemical reaction, what do the atoms do. Okay, you guys, if you have any time left over, I want you to study those key concepts. Study those key concepts. Study those key concepts. And I'll see you Thursday. I miss you so much, you guys. Can't wait to see you. All right, have a good day.